Very good morning, everyone. Today we discuss about the topic energy efficiency in electric motors and drives. Under that, first we have to discuss about electric drives. Electric drives is nothing but it is a system that control the motion of the machines. It particularly used to control the speed of the motor. That is the main purpose of electric drives. Means the drives can convert that electrical energy into mechanical energy to parameters like speed, position, and torque equations. This is the introduction of electric drives. Next, we discuss about the block diagram of electric drives. This is a basic block diagram of electric drives. So initially, this is a source. It may be AC or DC supply. And then the next block is power modular. The power modular can convert the source that supply for the need of the motor. It may be AC or DC, that AC can be converted to DC or DC can be converted to AC by using the power modulator. Means it convert the supply from the source to another form which is used for motor. The next motor, the motor can convert the electrical energy to mechanical energy and then it is given to the load applications. And now the main purpose is the motor speed can be controlled by varying the frequency or by varying the supply voltage in the power modulator. And then the speed, the motor speed can be sensed by using the sensing unit. You can sense the motor speed and it is given to the control unit. In control unit, the speed is compared to the reference here, whether the speed is low or not. If the speed is beyond the limit or speed is very low, according to that information, the control unit can change the control, the gate pulse can be controlled and so according to that pulse width modulation and control the will vary here in our modulator. Hence, if the input voltage is varied, the is very here. Hence, the speed of the motor will be controlled in this. That is called the block diagram. That is called the electric drives. This is a basic block diagram. Next, we go for types of electric drives. There are basically 4 types. In first, it depends on the supply, whether it may be AC or DC supply, NCTC, AC drive or DC drive. It's based on supply. And then second one is based on the number of motors. There are 3 types of the individual drive. Individual motor drive, each drive has its own motor. So that is the individual drive. And multi-motor drive, for a single machine, it utilizes a multi-motors. Okay, there are multi-motors to control a DC. It's called a multi-motor drive. And then the group drive. The group drive is nothing but that a common shaft will be connected to the all motors. Through that shaft, we can control all the motors. That is called the group drives. This is the type based on the number of motors. And then next, based on the speed, there are 2 types: constant drive and variable drive. And then fourth one is based on the control parameter. It may be a vector control, constant power control, or constant torque control. These are all the various types of electric drives. Next, we see about that variable frequency drives. It is a one kind of electric drives. So here we discuss about briefly about that variable frequency drives. That variable frequency drives is a device that controls the speed and torque of the electric motor by varying the frequency and voltage of the power supply. So by varying this voltage and frequency, we can able to control the speed of the motor. That is called a variable frequency drive. It essentially converts fixed AC power to variable AC power, allowing so the power, the fixed AC power is converted to a variable AC power. That means the frequency will be very here, hence we can get an efficient motor, efficient speed control of the motor. That is the main application of the variable frequency drives. And the variable frequency drive are widely used in the industrial applications to improve energy efficiency, optimize machine performance, and extended equipment life. And now we discuss about the block diagram of variable frequency drive. This is a block diagram. So here the converter is used to convert the supply, the input supply, whether it is, if it is AC means it is converted into DC by using a bridge rectifier, and then that is given to a DC bus. Okay, here that DC is again converted into DC. Any unwanted noises over there, it will be filtered here, okay, by using a function is taking place in this spot, and then it is given to an inverter. Again, the DC is converted into AC and it is given to a three-phase motor. Now, two times the power will be converted here. The first AC to DC and DC to DC, and then DC to AC here. So, this type of conversion is mainly to control the frequency of the motor. That is the main purpose. And then there is a logic control block. Here, that the two converters and inverters are there. So now the power can be controlled by using control logic or pulse width modulation control. So by using the pulse width modulation control, the converter or inverter, hence the voltage can be varied here. So hence we apply a variable frequency. So according to that, the motor speed can be controlled here. That is the variable frequency drive function. And then next we go for an working principle. Here already we see discussed in that block diagram. The same thing is happening here. So here the three-phase supply is going to rectifier, three-phase rectifier, bridge rectifier. Now that AC is converted into DC, and then it is given to a DC bus filter. Now it can be smoothen the supply by using the inductor and the capacitor filter is there, and then after that, after filtering, a smooth DC voltage, DC voltage supply is given to an inverter. Again, that inverter convert AC to DC, DC to AC, and then that is given to the AC motor. Now, the control unit can sense the output voltage, voltage, whether the motor will be maintain constant speed or not. If the motor is beyond the limit or below the limit, it can sense, and according to that, the pulse width modulation control will be activated here. Hence, the gate pulse will be varied. According to the gate pulse, the supply voltage will be varied. Hence, if the supply voltage is varied, the frequency also varied here. Hence, according to that, the supply voltage can be varied. So, the motor speed also varied here. So, this is the working principle of. Next we go for an advantages of variable frequency drives. Here, due to the variable frequency drives, we can save the energy and smooth starting and stopping, and improved process control of reduced mechanical wear and tear, and factor is included in variable frequency drives, and also a protective features. It can protect the motor from over speed like that, and then it also reduces the maintenance cost. Okay, why? Because it already that if you already speed of the motor ends, it can reduce the maintenance cost. This is the advantage of variable frequency drive. Next we go for a disadvantage of variable frequency drives. Here the initial cost is very high, and then that harmonic generations sometimes very happen here, and then complexity in operation and the cooling requirement sometimes, and then the next point is electromagnetic interference effect is there. These are all some disadvantages of variable frequency drives. And then next, the application of variable frequency drives. Here it is mainly used in HVAC system, and then in pumping systems and conveyor system, and then elevator and escalator. Here it is, these are only multi-motor drives. Okay, so here definitely using that variable frequency drives for that, and then some So the mixtures and the machine tools, industrial automation, so for this application we use that variable frequency drives. This is about introduction of drives and electric drives and classification of electric drives, and under that we see about variable frequency